Recording started.
All right, so we're going to talk about sequences, and there's lots of good definitions in the book or the ebook, but really for us, a sequence is just an ordered list of numbers. Any list of numbers, as long as it's in order, will work. So like 1, 2, 3, 4, 5. That's an ordered list of numbers. How about 2, 4, 6, 8? There's an ordered list of numbers. How about another one? 2, 4, 8, 16, 32. There's another ordered list of numbers. Any of those are sequences. We can define sequences in a lot of different ways, but one of the ways is just to give a function that will tell us the general term of the sequence. So here we go. We've got this general term. F of n is equal to 2n minus 5, and sure enough, they want us to find the first 4 terms of this sequence. The terms of the sequence usually are given by the little letter a with a subscript. So a sub 1 means the first term in the sequence, and the first term in the sequence uses a 1 for n. So let's go with 2 times 1 minus 5. 2 times 1 is a 2, so 2 minus 5, and 2 minus 5 is negative 3. So the first term in our sequence was a negative 3. The second term, a sub 2, is going to be 2 times 2 minus 5. 2 times 2 is 4. 4 minus 5 is a negative 1. The third term, written a sub 3, is 2 times, you guessed it, 3 minus 5. 2 times 3 is 6. 6 minus 5 is a positive 1. And our last term, a sub 4, is 2 times 4 minus 5. 2 times 4 is 8. 8 minus 5 is a positive 3. You can define a sequence in another way. Let me show you that way. This is a recursive definition. A recursive definition simply means I use the previous number to get the next term in the sequence. So what they usually do is they tell you the first term. In our case, the first term is a 3. And they say the next term, you get the next term by multiplying 2 times the previous term and then adding 1. So let's take a look at this. We're supposed to write out the first 4 terms. Well, the first term, a sub 1, we already know it's a 3. The second term, a sub 2, we get by writing out 2 times the previous term. And again, the previous term was this 3. So 2 times this 3 plus a 1. 2 times 3 is 6. 6 plus 1 is a 7. The third term, a sub 3, is 2 times this previous term, and again, the previous term in our case was a 7. So 2 times that 7 from the previous term plus 1. 2 times 7 is 14. 14 plus 1 is 15, so we have a 15 for the third term. For the fourth term, we take 2 times the previous term again. The previous term in our case was this 15, so 2 times 15 plus 1, and 2 times 15 plus 1, well, 2 times 15 is 30. 30 plus 1 is 31. So there we go. There's the first 4 terms in the sequence, 3, 7, 15, and 31. Those are the first 4 terms in this recursively defined function. Let's talk about some other sequences. You can have an arithmetic sequence. It's a lot easier than it sounds. An arithmetic sequence is when you add some number to every term. So let's say I start with the number 2. Let's say I'm going to add 3 every time. So if I add 3, I'll get a 5. Then I'll have an 8. Then I'll have an 11. And then I'll have, say, a 14, and it keeps on going forever. But the thing to notice is that every time I move from one to the other, I added 3. So from 5 to 8, I added 3. From 8 to 11, I added a 3. And 11 to 14, I added a 3. And I'm going to keep on doing that forever. This term that I added, that constant, is called the common difference. And in our case, the common difference is a 3. Now, we're going to identify the common difference by the letter D. And as I said, D in our case is a 3. It's called the common difference even though we are adding difference. Let me put an N in there too. Difference. Okay, it's called a common difference even though we're adding a number because if you were given the sequence to find this number, all you have to do is subtract any two consecutive numbers. So let's look at some notation for this, even though I can't spell. So here we go. The general term, a sub n, is equal to the first term plus n minus 1 times d, the common difference. Now, we already know from the previous example that our first term, a sub 1, was a 2. And our common difference, d, was a 3. So let's see. Our general term, a sub n, should be 2 plus, parentheses, n minus 1 times d, but d is a 3. So let's multiply this out. I'm going to multiply the 3 through the parentheses, and I will get a sub n equals 2 plus 3n minus 3. Let's collect our common terms there. So a sub n is equal to 3n minus 1. That's our general term. Well, let's check it and see if we get our first 4 terms or so. So if that was our general term, a sub 1 should just be 3 times 1 minus 1. Well, 3 times 1 is a 3, minus 1 is a 2. So yeah, that's the first term we started with. How about a sub 2? A sub 2 should be 3 times 2 minus 1. Well, 3 times 2 is 6, minus 1 is 5. Yeah, that's what we had. A sub 3 should be 3 times 3 minus 1. 3 times 3 is 9, minus 1 is 8. Yep, that works out. And a sub 4 should be 3 times 4 minus 1. Well, 3 times 4 is 12. 12 minus 1 is 11. Sure, those are the terms of the sequence I had in the last example. So, sure enough, this is the general term for that last arithmetic sequence. You can also have a geometric sequence. And in a geometric sequence, you start out with any number you want to. Say a 3, and this time multiply by some number. I'm going to make it easy. Let's just multiply by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48, and so on. The key thing to remember here is that we are multiplying by the same number every time. We're going to multiply by 2 every time. To get each term, we'll multiply by 2. Okay? That constant that we multiply by is called the common ratio. And it's generally the letter R for the common ratio. In our case, in our example on the previous slide, or on this slide, our example R is a 2. Okay, let's get some notation for this one. The notation here is the general term, and here's just another way of writing the general term as a function, f of n, is equal to c times r raised to the n minus 1 power. C will be the first term. Now the first term in our case, we started out with a 3 here on our example. R is the common ratio, and the common ratio is a 2. So our function, our general function, general term, should look like f of x is equal to 3 times 2 raised to the n minus 1 power. Well, let's check that. So if f was a 1 for our first term, we should have 3 times 2 raised to the 1 minus 1 power. Well, 1 minus 1 is 0, so 3 times 2 to the 0 power, and anything raised to the 0 power, remember, is a 1. So I get 3 times 1, which is just 3. And that is the term we started with. F of 2 is going to be 3 times 2 raised to the 2 minus 1 power. That's 3 times 2 to the first power. 2 to the first power is 2, so I get 3 times 2, which is 6. And sure enough, that was 6 is our second term. F of 3, let's see if that checks out. It's going to be 3 times 2 to the 3 minus 1 power, which is 3 times 2 to the second. 2 to the second is 4, so it's 3 times 4, or 12. And last, let's check the last term there. We had f of 4, which will be 3 times 2 raised to the 4 minus 1 power. That's 3 times 2 to the third power. And of course, 2 to the third power is a is an 8. 3 times 8 is 24, so it checks out. This is our general term for the geometric sequence that we wrote down on the previous slide. That's it for sequences.